Okay, now we estimate the cost of capital. We can write out the formula, the weighted average cost of capital. Yeah, but this formula is not correct. I will tell you why. Okay, look at this example. This is an example of short version of an income statement. Yeah, we have sales, we have cost of goods sold, and we come up with some other costs. Yeah, and then we have earning before interest and tax, EBIT. And from this earning before interest and tax, we subtract for interest, trừ ra tiền lãi ha. Then we have earning before tax, and then we pay tax, and then we come up with earning after tax or net income. Okay, now, and from this after tax, we pay dividend to shareholder, and we also, we keep some earning. We retain some earning. Yeah. Okay, where is the debt? Do you see where the cost of debt? Here, the interest. This is where we see the cost of debt. And where the cost of equity? Where does it show that the company had to pay for the shareholder? Here, dividend or retained earning. Yeah. However, the position of interest, they are both the costs. One is the cost of debt and one is the cost of equity. Both are parts, both are components of the cost of capital, but they are in different positions in terms of tax. In terms of tax, where the tax? Whether the company they pay tax here, they pay tax here. So basically, the cost of debt is before the company they pay tax, and the cost of equity happened after the company they pay tax. And why that matter? Why that matter? They are both considered cost, right? They both consider cost. But one cost you are allowed to subtract it. You are allowed to deduct it before you pay the tax. But the other cost, you are not allowed to subtract, to deduct before you pay tax. What do you prefer? What do you prefer? I will give you one example. Okay, suppose that you graduate, you get a job, and you get the salary, and you have to pay personal income tax. Yeah. So what do you prefer? You get the salary, you spend all the costs, you pay for rent, you pay for food, you pay for traveling, and then you pay tax on the left. Or you receive your salary, you pay tax, and you spend the rest. Which way do you prefer? You prefer the first one, right? You prefer that when you receive the salary, you spend you spend all the costs, like you pay the rent, you pay for the food, you pay for your traveling, for every cost you want, and then you pay tax on the left. That's what you like. So same here. Yeah, the cost that you are allowed to deduct, yeah, before you pay tax, that will benefit you. You pay less tax, right? So you see, they are in the position, they are in the cost of debt and the cost of equity here, they are in different position in terms of tax. So if we put them like this in one formula, yeah, it does not provide consistent estimate. Therefore, we have to bring them into one point where they reflect the same thing. Yeah, the same position in terms of tax. So I bring the cost of debt to the after-tax cost of debt to here. Yeah, like the cost of equity. So by doing so, I multiply for 1, subtract for tax rate with T. Okay, here in my formula I use DC. That is the corporate income tax rate. Yeah, corporate income tax rate. Okay, here we have one important concept in corporate finance, that is the tax shield, lá chắn thuế các bạn. Okay. Yeah, but then we will see this tax problem again in chapter 5. So we will talk about it in chapter 5, not now. Okay, but now remember the WACC formula. We had to multiply with the term the RD for 1 minus DC. Yeah. Okay, this is an example. We have equity information, debt information, and the tax rate, and now we have to compute the WACC. Okay, on the other slide, the following slide, I already saw the problem. So please save time to take a look at the example, and then try to do the example, to work on the example yourself, and then compare your result with the result that I already uploaded. Okay. Okay. So that is the cost of capital. Now we already know how to estimate the cost of capital of the company. That is the combination, the weighted average of the cost of debt and the cost of equity. And note that the cost of debt is after-tax cost of debt. But now the question is, if the company, they have different divisions, different departments, different like small company, holding company, for example, then the cost of capital may not be identical across different divisions of the company. Some division may have higher cost of debt than another. So what can we do? Okay, first of all, we use the same WACC as the discount rate for the projects that have the same risk as the firm's current operation. Yeah, and if the project does not have the same risk as the firm, then we need to determine the appropriate discount rate for that project, and we have several approaches to do so. For example, what would happen if we use the WACC for all the projects regardless of risk? Assume that the WACC of the company is 15%. Then look at the project ABC. We have the required return and the IRR. So look at this example. If we use WACC for all the projects to determine if we accept a project. So basically, if we use WACC, we will compare WACC and the IRR. And if WACC is smaller than IRR, then we accept the project. So if we use WACC, we will accept the project A and B, right? Because, yeah, the IRR is greater than the cost of capital. But if we use the IRR and the required return as criteria, you remember in chapter 2, the required return had to be less than the IRR in order to accept a project, right? So we don't accept A, right? Required return is greater than IRR, and we accept project B and project C. So you see, If we use WACC, we will accept A and B. And if we use IRR and the required return, we accept B and C. Yeah, in a way that the two choices lead to different choices. Then we accept the project that we should not, and we reject a project that we should not. Yeah. So what can we do? The first approach is the pure play approach, that we find a company that have the same product or service that we are considering as the same as our project, and we compute the beta for each company, and then we take the average beta, and we use that beta along with the CAPM to find the appropriate return for the project of that risk. And you know how to find the required return according to CAPM. Yeah. However, this approach is difficult because it's not easy to find the company that are specialized in the same product or service that our project is. Okay. So another approach is subjective approach, that we consider the project risk relative to the firm overall, and if the project risk is riskier, is higher than the firm overall risk, then we use a discount rate that greater than the WACC, and vice versa. We use a discount rate that less than the WACC. Yeah. Okay. For example, if the project risk level is very low, then we take the WACC of the company, we subtract for 8%. If the project is have low risk compared to the general risk of the company, then we take the WACC, deduct for 3%, and blah blah blah. But remember, this one have no scientific evidence, and this is just the rule of thumb. Yeah, the common practice. Okay. The last problem in this chapter is about the flotation cost chi phí phát hành. Yeah. So the required return depends on the risk, but not how the money is raised. But however, the cost of issuing new security, as I mentioned, can be significant and should not be completely ignored. Yeah. So let's see one example to see how. So look at one example to understand the role of flotation cost in evaluating a project. Okay, your company is considering a project that costs $1 million, and the project will generate after-tax cash flows of $250,000 per year for 7 years. Okay, this is the cash flow. 1 million. Yeah. Cash flow of 250,000. Yeah. 1, 2, and for 7 years, 250K, 250K. And the WACC 15%. And the firm target DE ratio is 0.6. So WACC DE. And the flotation cost for equity is 5%. I will write down the FA, 5%. And for cost, flotation cost for debt is 3%. FB, this is FE, and this is FB, 3%. So what is the NBV for the project after adjusting for the flotation cost? At the beginning, we had to calculate what is the flotation cost, the general flotation cost, or the flotation cost of capital. So we use the same approach with WACC, that we apply weighted average cost, flotation cost. So this is the one with the flotation cost in general. So that is the weight of debt, and this is the weight of equity, and multiply for the reputation for flotation cost accordingly. And how we come up with this number, the D and WE. Okay, and from this, we have D over E is 0.6. So if E is 1, then D is 0.6. Agree? I assume that E is 1, then D is 0.6. Then V equal to D plus E is 1.6. And now I can calculate the weight of E. So E over V, the CWE, is 1.16, and this one is 0.625, and WD is G over V equal to 0.6 over 1.6, and this is usual 375. Okay. Okay, and now this is the flotation cost of capital. And we will calculate in order to accept the project, right? We had to calculate the NBV to see if the NBV is greater than 0. Okay, so remember how to do the NBV? Yeah. So the BV of the future cash flow, this one is the BV of this flow, and then you plus you bring it this one, you plus with the initial cost, but this one had to adjust for the flotation cost. So the NBV, without the flotation cost, the NBV will be like this. So 1 million plus 250,000, 1 plus WACC. I replace WACC by 15% power D, with D come from 1 to 7. This is the NBV, right? And this NBV is, you calculate that is 40,105. So see, this greater than 0, so we accept the project. But wait, this NBV doesn't take into account the flotation cost. There are no flotation cost here, right? But in our case, we have flotation cost. So what does that mean? It means that the 1 million you get as year 0 here, you have to pay flotation cost before you get 1 billion. So in order to get 1 billion, $1 million to invest in the project, we had to come up, we had to mobilize, or we had to, this is the number we had to do, we had to divide for 1 plus 1, subtract 4.25%, and this number is, can you calculate? Okay, so this one is 1 million 4 3 8 6. Yes. $. So after you pay the flotation cost, this is the number you had to invest, or this is the number you had to mobilize. Yeah, and after the flotation cost, you get 1 million. Okay, so the actual cost at zero is not 1 million, but this number, and you replace this number to this position, and you get the NBV of this. And now NBV become negative, and as the result, you do not accept the project. Okay, so this is the end of chapter 4. Thank you for watching.